All right, let's get started with Chapter 6, Operations in the Cloud, Observability with Cloud Operations. So, cloud environments demand more than deployment. You need to monitor performance, log critical events, catch errors, debug behavior, and profile your application's resources use, all while your system is running. This chapter explores Google Cloud Operations Suite, formerly known as Stackdriver. It provides a powerful set of tools for monitoring, logging, error reporting, debugging, profiling, and tracing. Let's begin with the foundation. Cloud monitoring and logging. Google Cloud Operations lets you monitor both GCP and AWS resources in real time. It collects metrics, visualizes them in dashboards, and integrates with alerting to notify you of uptime, errors, or anomalies. Cloud monitoring requires setting up a monitoring account linked to your GCP project. A single monitoring account can monitor up to 100 projects. You can also monitor external AWS accounts via connector projects. When billing is enabled and resources are created in your project, you can SSH into your virtual machines and begin setting up monitoring via cloud operations. Logging, unlike monitoring, does not require a separate monitoring account setup. How to set up cloud monitoring. First, you enable the API. Fortunately, this is already done. In this, you would navigate to the Google Cloud Console, go to API and API and services. All right. All right. Once you're here, go to the library and you search for the Cloud Monitoring API. So let's say Cloud Monitoring. There we go. And there it is, right? Click that and enable it, right? So next, you can install the monitoring agents. Okay, so in this, we can do this for Ubuntu, Debian, or for CentOS. So let's try this for, let's see, let's reconnect. It's loading up the shell. Now let's get this to go. Perl. So this is adding the agent. So this is done. Let's write the package, put the list, updated this. All right, so it's still installing. Looks like it's getting this, all the packages. Okay, so read the package list right here. Building dependencies, unpacking everything, unzipping everything. And so it's installed, okay? And then we could do this for CentOS or RHEL, which is the Red Hat Enterprise Linux. So we bash that, add the ops agent. And so it says ephemeral system-wide changes will persist beyond the session end. So this is installing that agent. All right. This is going to do the similar thing, but with a different image type. For the VM types, you see it'll still go through, get all the packages, read them. All right. That's good. All right, so how do you create a custom dashboard? In the console, you'll go to monitoring, which is where we're at, go to dashboards, which is where we're at, and then click create dashboard. Okay, and you can add charts by selecting the add widget. And so let's add this metric, line chart, widget title, let's say VM CPU usage. All right, and then select different metrics, standard mode, compare to past, let's say, 12 hours threshold. 50. Yeah, that should be good. And then, oh, select a metric, CPU. Oh, wait, operations type, VPC network. Oh, oops. Operations. Let's see. I think it's under operations. Concurrent operation. No. Ba, 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 ba. Consumer. Let's see. Monthly trace spans. No. All right. Let's try inactive. There we go. All right. Oh, VM instance. Okay. CPU. There we go. Now we're getting it. CPU usage. Total. Oops. That's the total time the CPU spent in different states. Apply this. So we would get this, but we don't have any CPUs. When we click apply, we good to go. So I'm going to click cancel, so I don't have this here, but there's a bunch of different metrics you can do. And you can set up an alert policy. So go to monitoring. Oh, nope, there it is. They moved it around a little bit. Alerting, create policy, and then define the conditions. So select a metric again. Skip. Okay. So you can set CPU. So VM instance, CPU utilization, apply. Then each time series, the rolling mean, filters, empty. CPU state is, oops, active. Whoa, wait. So this project, okay. Project equals just jewels. We're done with these. And then we're done with that. Or is that the project? No, that's the project name. I got that wrong. No. No, it's okay. It's okay. But as long as you understand that, right? And then next, what's the threshold? You set the threshold. If it's above, let's say 75%. Okay, since there's no CPUs, this won't go. So you name your policy. So this is the VM. Or you could do it if it's not, if any time system has no value, or you can forecast this. So there's a bunch of different ways you can send this. All right, next, notification, there you go. Now you can name it, and you can send it to whatever you like, Google Chat, PagerDuty, Slack, you have webhooks, you have email. There's a bunch of different ways you can set these notifications. So you can have a notification record log, and then set the auto close duration. So I would say 12 hours, right? So it'll set, if it's absent, it'll select the duration after which the incident will automatically close, right? So you might want to tighten that up. And then you can set some labels, policy users, and the security level threat. I'd say warning for something like a VM CPU usage, and then any documentation you'd like for here, right? And so you can use Markdown, you can use variables to indicate time, date, that type of stuff, right? Then you name it and create. Oh, um, um, policy. Next. What did I miss? Some fill incorrect. Application. Oops. I didn't enable App Hub. So there's a lot of different things that you'll have to enable along the way. So you can enable this. Okay. So that's good. Okay. Service. So you have to set this to link this to enable the alert policies, which is okay. All right. Notification table, we'd have to set that. And then review this. It's not going to let us review. Okay. This is with the review to make sure everything was right. All the notifications, all the channel types, notifications, any documentation you want. And then you click create policy. All right. Project types in the cloud. Okay, let's go back. All right. You have a hosting project. This stores, let's discard this. This stores dashboards, uptime tracks, and alerting policies. Okay. Let's see. Oh, let's see that. Okay. This should not run resources. You have an AWS connector project. Let me see if I can find this here. Well, you can find more information here. Okay. This is created when linking an AWS account. Okay. You sends logs and metrics for analysis. Then you have a monitored project. This is where your production apps run. Cloud operations captures logs and metrics from these instances. So how to configure project monitoring? Go to monitoring. Okay. Go to settings. Boom. Okay. And then select projects. Let's see. JScopes. Create JScope. Add the projects. Okay. And you select the projects from here. You'd select this from this list. This project's already monitored, so we're already working in this, right? And you'd add it. And then configure AWS integration. Okay. Settings. Let's see if I can find AWS real quick. I haven't done this in a minute. What's that? Why am I not seeing this? Settings. Let's see if I can find this here. I don't see it. That's unfortunate. Okay, that's not a big deal. But basically, you'd be able to add the AWS account. So, connection, AWS settings. So you have to write code for this for S3, which is not exactly what we're looking for. These are the IAM policies. That's not what we're looking for. That's not what we're looking for. Okay. Connect to AWS configuration. There we go. That's probably it. So you probably, so now you have to go to security settings, security command center. Okay. Okay. So security. Let's see. Sources. Let's try this. Well, that's going to be the projects. This is, we got to click the project here. So just Jules Kubernetes. Still won't let me. Oh, wow. This is crazy. Nope, won't let me. But it won't let, probably, yeah, I have to create. But basically, you want to go here, click this project, then add an AWS account to this, right? So let me see if, am I missing connectors? How about that? No, I don't see it. Zero Trust. Let's see if the marketplace has something. Nope, it's not in the marketplace. So it is in here. And I think it is through this. Okay. But with this, you'll follow the wizard to create the necessary IAM roles in AWS. So that being you'd have your AWS account, then provide the AWS account ID and external ID. And you can customize the dashboard, set daily or weekly email reports, and configure custom health checks directly from this cloud console. All right, so logging. All right, let's go back. So logs can be filtered by resource type. We showed you the VM. It can be done by firewall rule, log level, and time frame. And you can stream logs in real time. Click into the logs from dashboard charts and use filters to dig into system events or user-defined log entries. Okay, so this would be on this dashboard, right? Let's see firewall rules right here. Okay, so cloud logging also enables you to route logs to multiple destinations like cloud storage, BigQuery, or PubSub, create log-based metrics, set up a log-based alert, and configure log exclusions to control costs. Okay, navigating to logging. Let's see. Let's go back. See log. Logs explorers. Log explorers. Okay, and we can use the query builder, or we can write queries in the log querying language. All right, so there's a wizard, or you can do it here. So you can create a log sync. All right, as well. Let me open that up. Okay, so you could do all this. So you can run a query. You can write the query here. Let's say resource type, see instance, and then severity, error, run the query. So it doesn't have anything because we don't have an instance here, which is okay, but that just gives you an example of what you would want to do. So we can also create a log sync. Let's go back to monitoring. And then, this is not, we go to log router, and then we can create a sync. All right, create a sync here, and click on that. We name this just tools sync, right? And then sync description, add that information. We get the destination. So this could be BigQuery, Cloud Storage Bucket, PubSub, Splunk, Cloud Project, right? And you can set another resource, right? And then you can, let's say the other resource. And then you enter that information there. It's not going to let us, right? From here, you define the inclusion filters, right? And then things you want to route, and then things you want to exclude. So the exclusion filters and things you want to skip. And then click create sync. You can also create a log metric. So we can go to metric. Okay. So go to Metrics Explorer. Let's see. I see it add a query, but let me see if metrics management might be a better option. Okay, so this is managing the metrics you already made here. Okay, so from here, add a query. All right. And then you choose metric type you want, right? So this is the metric you want to look for. That could be VPCs, that could be networking, anything. Add a filter, right? And then you can select the aggregation. And then, let's do this. Let's do this to be, say log space metrics, byte stream into the buckets. Okay. Log source, sum, bind, none. So you have to understand this, and then you save the chart. And then it would show up here, a metrics manager, and you'll be good to go. And let's see, you can also set up an exclusion. All right. So from here, you go back to log router. Okay. And log router, you can create this exclusion. Oh, well, I showed you that. It got combined into it. So that's fine. All right. So then you have cloud error reporting. Error reporting automatically aggregates and displays application errors. It works across Google Cloud Services, including App Engine, GKE, Cloud Run, Cloud Functions, and Compute Engine. It automatically groups and deduplicates similar errors. So it shows error line number, file, and URL. Errors are listed under the error reporting section. All right. And you can enable auto reload to update the error list every 5 seconds. So let's see error reporting. Oops, clicked on the wrong one. So this will go here, right? So you can set this up here. So from here, you can click an error to see its stack trace. Oh, what did I click? Okay. I did click set this up. All right. So you can write this using the API, and you can collect the error reporting by documenting here, right? So you can review the list of errors once you've set this up. Built on GKE. So you can configure it for this app engine, app script, Cloud Run, Google Compute Engine, GKE, and EC2s, Amazon. All right. And for any of these, you can set up the error group to see the stack traces, currents, timeline, affected versions and services, and sample error logs, right? And you can set up error notifications. So in this, you can click the settings, which we're not going to do. Enable email notifications. Let's see if we can do this. I don't see it here, but that's okay. But you can set up notifications, all right? And then when you configure a notifications channel, like email, Slack, or PagerDuty, you can choose to be alerted on new errors or error spikes. And you can leak errors to the source code. So say for GitHub, for Bitbucket, etc. And in the error reporting settings, you can link your source code repo, let's say from GitHub or Bitbucket, and then configure the source code integration. And the errors will now link directly to the relevant lines in your repo. All right. So let's see. I don't see it. Let's see. Cloud Debugger. Yeah. Operation Suite. Let's see if Cloud Debugger is here. Why don't I see it? So Cloud Debugger lets you inspect and analyze your live application without stopping it. With Cloud Debugger, you can capture snapshots of app state, variables, and call stacks, inject log points, custom logs in production without redeploying. And the debugger adds less than 10 milliseconds of latency and supports App Engine Standard, App Engine Flexible, Compute Engine, Google Kubernetes Engine, and Cloud Run. It works best in Google Chrome using local HTML5 APIs, and code never leaves your browser. Okay, so I don't see it. Let's see. All right, so each snapshot highlights the specific line in the source code and logs the variables at that moment. You can switch between applications, examine history, and request the application to send a snapshot on demand. So how do you use Cloud Debugger? Let's try this. There's that. Let's see. So if you go here, starting at 50% per hour, there you go. That's going to cost. Offline debug. All right. And you can select your code repo. And then, oh, this is for it. No. This is Apogee. Sorry. Cloud debugger deprecation. Oh, it was deprecated. Ooh. It was shut down in May. So that is no longer relevant. Okay. So let's go to log points because that might be more relevant. So let's click out of this. Let's click out of this. All right. Let's see. Log point. Log point. Log point. Google security operations. Okay. So LogPoint lets you add runtime logs to your app without redeploying. All right. And then let's configure the integrations. All right. It lets you observe values in live traffic. And then it sets expirations, usually about 24 hours. And you can track your usage in LogPoint history. Okay, let's see. All right. So this is ideal for debugging code paths during production load without impacting performance. So how to use this? You need to use it, one, by first finding it, log point, Google security. Let's see. Mhm. I don't see it. This might have been this might not be available right now. That's unfortunate. Well, slug point is supposed to do a lot of those things without shutting down your application. Maybe it's cloud logging that I'm supposed to be looking for. Log-based metrics. Let's see if that's it. Ah, yeah, so this looks a little bit closer to what you're supposed to be able to do. So you can configure this to define and create log-based metrics within your project. This is probably closer. Yeah. And you can use the analytics to be relevant, which we just reviewed. That's okay. Okay. Let's see. The next one is here. Oops. Hmm. Cloud Profiler. Let's see this. Okay, so Cloud Profiler. There we go. Enable this. So the Cloud Profiler captures how your application uses CPU and memory over time. It differs from monitoring by tying resource usage directly to source code. With it, you can find inefficient functions, identify memory bloat, and resolve thread contention. So Profiler supports the following languages: Go, Java, Node.js, Python, and C++. And it supports apps running inside or outside of GCP. So let's see if we can find. So it's enabled, it's a public API. You can get these by the response code, the API method, credential. There's a lot of different ways you can select the graphs, right? And then let's see, the library has a lot of information here. So once you have this, once you have this configured, the profile will start collecting data and display usage, heap size, mutex contention, and wall time through a flame graph interface, right? So it'll show this all right here. Okay, so how do you set this up? We just enabled it. We can add the profiler agent. Authorize this. All right. And we can add this agent. Agent path. Let's try. Let's try with Python. Oops. Mm, let's try this. Didn't add it. There's supposed to be different ways you can add it depending on the language for Java, for Python, for Go, right? And so then you should be able to log in. Let's see. Um, you should be able to select these for the quotas and the requests for the filters and go forward. So the profiler's concepts are this. It's supposed to adjust for CPU time, so the active processing time of a function, heap profiling, which is HEAP. This is the memory usage and allocation issues. The contention, this is the lock contention for concurrent operations. Threads, this is the thread activity in applications. Wall time, which is the total elapsed time spent in a function. So if you're going to read the graphs, which we'll go back to here, All right. This is going to be measured in a couple of ways. One, the x-axis, which is the width, right? This is going to represent the proportion of time spent in each function. And the y-axis is going to be the depth representation of the call stack, right? And then you're going to be able to look for hotspots, right? Wide blocks that indicate that functions are consuming significant resources. And then you can use filters, right? Okay, let's see. Quotas, limits, alert policies, and then you can have credentials that can be associated, right? And then you can have filters like hide the stacks to simplify the views, and you can focus on specific packages. Okay, let's go back to monitoring and see if we can get to trace. Cloud trace. Let's cloud trace. We have to enable this. So this is an API that sends it straight to CloudTrace. You could probably use that for something external. Okay. But CloudTrace is going to be a distributed tracing tool that'll visualize request latency. So it'll work with Google App Engine natively and other services with instrumentation. So it'll collect all call times, endpoint latency, and internal call chains. And it's ideal for understanding performance bottlenecks and helping you solve problems. So Trace helps answer how long do requests take, where are delays occurring, and what does a complete request lifecycle look like. So to enable it, we can go back to the API, which we're going to manage. This is aid enabled, okay? And then from here, we can use implementations for our code for Java, Python, and whatnot, right? So what we want to do is review the list of recent requests by these methods, which we've already done, and then you can click on a request, which would be down here, or the errors here, and view a detailed latency timeline. And so we can use the waterfall view to identify slow components, and it can generate an analysis report across request URLs, or URIs, excuse me. So you can compare this latency across different versions or regions and set up trace-based SLOs and service monitoring. Please note, CloudTrace is automatically enabled for several Google Cloud services, but for apps running in GCE VMs, GKE, or on-prem, you'll need to integrate the CloudTrace SDK for programming languages like Java, Go, Node.js, Ruby, C#, and PHP. Okay, so let's look at service monitoring. Okay, so service monitoring. Service monitoring helps you monitor your user-facing, here we go, your user-facing services with SLO, right? Which is the service level object management, SLI, the service level indicator measurement, automated alerting with when the service performance degrades, and integration with cloud monitoring for comprehensive dashboards, right? This capability connects the dots between infrastructure metrics and actual service performance. Okay, so how do you set this up? So you would go here where we are, SLOs, and then you could create a service, all right? Select the service type. Let's say just to, actually, that's interesting. Custom service. So you select the service types from here: App Engine, Kubernetes, Anthos, Cloud Run, etc. Right? And then from here, you could define the service details, right? And then within the service, let's see, so define it here. And then create what you're looking for, right? You can configure alerting policies once you're configured, but we don't have any activity going in this account for this. And then from here, you'd be able to create the policy, set up a dashboard, and then add the SLO widgets to monitor your service health. And you'd add related metrics to correlate with service performance with infrastructure metrics. Okay, so now you understand the suite of tools Google Cloud provides for observability. This is for monitoring your resources, logging system and app events, catching errors, debugging live code, profiling resource usage, tracing full request flows, and monitoring service levels. Together, these tools form the backbone of Google Cloud operations, helping you deliver faster, safer, and more reliable applications. So here's a couple of questions we can go through just to give you a little, let's say, feedback. All right, based on the Google exams that would come about. Okay, so what's the best approach for monitoring both GCP and non-GCP resources? Cloud monitoring. This can be configured to monitor both GCP and external resources, including AWS. For on-premises or other cloud platforms, you can use the monitoring API and agents to collect and send metrics to cloud monitoring for a unified view. So you install the op agents on the non-GCP VMs. You can configure the agent to send metrics to Google Cloud and create a custom dashboard that includes both the GCP and non-GCP resources. And you set up a unified alerting policy across all resources. Question 2, how can you monitor latency for microservices architecture? CloudTrace. This is ideal for monitoring latency in microservices architectures. Why? Because it allows you to trace requests as they travel between different services, giving a detailed breakdown of where delays occur in the request path and helping identify bottlenecks. So how would you do this? You'd instrument each microservices with an open census or OpenTelemetry library. You configure trace sampling rate appropriately, and you'd create trace annotations for important operations, and then set up trace-based SLOs for critical service paths. Question 3, what's the recommended approach for long-term log retention for compliance? We didn't directly go over this, but we did talk about it a little bit. Basically, you want to export your logs to BigQuery for long-term analysis and querying capabilities, or to cloud storage for more cost-effective long-term retention. You can set up log syncs, which we did talk about, to automatically route logs to these destinations with the appropriate retention policies. So how would you do this? You create a log sync targeting cloud storage or BigQuery. For cloud storage, you configure the lifecycle policies for long-term retention. For BigQuery, you set up table partitioning for efficient querying and document the retention configuration for compliance results. Okay, next question. How can you detect and respond to performance issues before users notice? You'd implement a combination of uptime checks, alerting policies based on the SLOs, and proactive anomaly detection. And you'd set thresholds that trigger alerts before users are impacted and automate responses where possible through cloud functions or webhooks. And you do this by setting up uptime checks for multiple regions, configure SLOs with buffer thresholds, which we showed you. So let's say 5%, 10%, 15% of error budget consumption. Implement the anomaly detection on the key metrics, and then run books for common issues and automate first response where possible. Next question. What's the best practice for reducing log storage costs? Implement log exclusions for high volume, low value logs. Use log-based metrics instead of storing full logs when appropriate, and set up appropriate log retention periods. Route only essential logs to BigQuery and use cloud storage with lifecycle policies for cost-effective archival. Implementation steps would be to analyze the log volume by type to identify high volume sources, create exclusion filters for debugging verbose logs, and replace full logging with metrics for high volume events. And you'd use tiered storage for logs, recent in logging, medium term in BigQuery, and long term in cloud storage. By understanding and implementing these cloud operations tools, you'll gain comprehensive visibility into your cloud environment while optimizing performance and managing costs effectively. Next up is Chapter 7, Identity and Security in Google Cloud.